Hello and welcome to this video demonstration of HazMap3D. In this video we're going to look at the various routes to compliance that you can use HazMap3D within, focusing mainly on target fire size and target gas cloud methodologies. Now initially we're just going to add in our 3D drawing as you would typically do at the start of any project using HazMap. Now the 3D model we're going to use for this example is the test ground at Micropack's facility in Portlethen. This is the test facility which is used in the validation of HazMap3D and also when we test third-party flame and gas detectors, not just for their performance but also for their effect in various different environments. In the Aberdeen area in Scotland we get quite a wide range of weather, so that's quite useful for other detector manufacturers to really put their detectors through their paces and see how they perform. So regarding the methodology we're going to apply for this study, I'm just going to select the Grades tab. We can see the project info for this specific project. We're going to keep the ISATR document as the standard methodology, and obviously it's an onshore facility, so onshore open, we'll keep that selected as well. Now based on how you can assess the flame and gas detection coverage using the ISA document, these numbers are all entirely editable and user specified. So the different fire sizes that you would want to use for alarm and control action may differ depending on what site and what risk assessment has been carried out in the lead up to the fire and gas assessment being carried out. The number of votes required is also very important in what kind of coverage factors we achieve after running the assessment. Often on an onshore site this can vary between 1 out of n and 2 out of n voted systems. For the purpose of the initial assessment we're going to keep it at 1 out of n. When we look at the inner and outer distances, this is essentially the size of the grade which will appear and the distance that that grade will extend from each of the vessels that we're about to grade in the video. So for the purpose of this video we're just going to keep these values as per the default initially. So I'll go into the 3D environment and I'm just going to select a couple of grade Bs and a little grade A as well. Okay. Now obviously these pieces of equipment are real pieces of equipment which will typically have a tag from the plot plan. So we're just going to put in some information which will be useful further down the line in identifying which piece of equipment has been graded. Okay. Now essentially what this means, when we go back into our grades tab, these two orange bubbles represent our grade B, which is our moderate risk. And essentially we're targeting a 100 kilowatt fire for alarm. And because it's a 1 out of n voted system, that 100 kilowatts is really all we're going to be concerned about. Similarly for grade A, because it's a higher escalation potential, we're looking for a smaller fire size. So we're looking for 50 kilowatts in that area. So at this point, we'll just hide the grades and we're going to add in a couple of flame detectors into the area. Okay, obviously initially it's a generic flame detector which is applied, but for the purpose of this video, and for what's actually out on the test ground in that location, we'll put a Micropack device in. Obviously it recognises exactly the orientation that flame detector is looking at, and we'll just bring the sensitivity down just to keep the field of view within the 3D model. Remembering also that this cone that you can see is not the full detection characteristic of that flame detector. This is purely just representative for the assessment. So when we look back at the grades, that's obviously crucial for different fire sizes. We don't need to change this cone based on what fire size is applied within the area. The software will recognise what target fire size is needing to be assessed within that area and will automatically calculate the coverage based on which flame detector has been installed into the area. And that's entirely based on third-party verification of flame detectors, third-party provided data that Micropack have gathered, which is completely third-party validated and completely open for the users to review that data. So we're now going to populate the area with the remainder of the detectors. We'll just rename this detector 3001. Okay. Now, the software has recognised that the previous detector that was added was the Micropack FDS301, but it's actually a Detronics device that we've added in this example here. So we'll put that detector in and make sure it's fully accurate. Okay, and we'll rename that one also Treasure 2. And we'll add in a third device just to make sure the coverage is as per the test ground. Okay, so we've got three flame detectors within the area, and we're now in a position where we're going to assess the volume. Okay, so to assess the volume, we're just going to call it the proposed layout. We have our details of the shoebox volume that we want to assess, and we can just have a look at that shoebox to make sure it encompasses all of the hazards, which it does. So we're happy with that, and we can now run the assessment. Okay, so obviously because it's a 1 out of n system, we're only going to have our 2% coverages, which is green for coverage of the target fire size or red for no coverage. We also have that split up between the grade A and the grade B. Obviously we had our grade A vessel here and our 2 grade B vessels behind. Now what we're actually going to do now is just review how that changes when we change the target fire sizes and the voting requirements. So if we change that to a 2 out of n voted system, and we change our fire size for alarm to 10 kilowatts, which essentially means we want to detect a small fire, but we don't want to take executive action on that yet. We want to wait and see if the fire is going to grow to a significant point, at which point we would want to initiate our executive actions and then shut down when that fire size gets to the 50 kilowatt radiant heat output value. Similarly, for the orange, we're going to make this 50 kilowatts RHO for alarm and 100 kilowatts for control action. So we're making the system a little bit more stringent, but really just to demonstrate the difference in what kind of coverage you would expect to see. Now it's very important at this point to recognise that really you can get 16 different target fire sizes in a single assessment in HazMap. And that's something that's really important with various different guidance documents which have to be followed in the industry. Guidance documents will not simply give you one fire size that must be detected in all areas. We need to make sure it's a performance-based system, which means in the same assessment we could have, for example in HazMap, up to 8 different grades within a single area, and those grades may have different target fire sizes for alarm and control action. So the software has to be able to account for all of those different target fire sizes in a single assessment, and essentially we can carry out that assessment without having to go into every flame detector and change the sensitivity, because the software knows the calculation and carries out that calculation based on the target fire size. So we're going to go ahead and run that assessment now. Now you can see that obviously we have the introduction of some orange coverage here, which is our 1 out of n coverage. For alarm only, because we've changed the voting requirement to a 2 out of n system. And because it's quite a small area, we've not actually seen the impact of the sufficient control action value, but with late alarm, the impact of having 2 different fire sizes within the same assessment. But essentially there are 2 more colours which you could see within the assessment. Simply just to represent the effect of the differing fire sizes within the same grade though, what I'm going to do is I'm just going to make the alarm value for grade A 5 kilowatts. Now essentially it would be ludicrous to actually target a fire size lower than around about 10 kilowatts. 10 kilowatts is typically the smallest fire size that you would actually want to detect, and remembering that that's in radiant heat output, not total energy output or energy release rate. So if we make the alarm value 5 kilowatts and then we run that assessment again, we should start to see, I would suspect with the position of the detectors, we'll start to see a little bit of yellow coverage, which is where that alarm, fast response alarm coverage isn't actually included in the assessment. So we can run that assessment now, and yeah, you can just see the tip of that fire size moving out of the range of our detector here. And we essentially get this yellow, which is sufficient control action. So the 50 kilowatt fire size is detected perfectly well, but this 5 kilowatt that we want for a fast response alarm is not yet detected. So the fire has to grow to a larger fire size than is adequate to be detected within this area. Now in this video, obviously we've only looked at flame detection. This is only half of the problem. Gas detection obviously uses entirely different methods to assess the adequacy, but you can check out our video on gas detection compliance, and you can also, if you've got any questions, get in touch with any of the contact details in the video description, and myself or my colleagues at Micropack will be delighted to help you out. Thanks for watching.